I'm Steve Mann and this is Paper Classroom. Welcome to another science tutorial, and in this particular tutorial we're going to talk generally about valence and bonding. Once you've watched this video, you should really go and look at the videos on individual types of bonding. Valence is just another word for combining power. So how many atoms of one variety will combine with how many atoms of another variety, or how many it has the potential to combine with. And this is governed by what we've seen in other videos as the magic numbers, which are 2, 8, 8, 18. So as an example, this is an atom. This is the very first orbital, the K orbital, and ideally that atom would like to have 2 electrons in it, no more, no less. This atom has 2 orbitals, the K and the L, and in the second orbital it would like to have 8 electrons. It's a full orbital. This atom, we're now seeing it's got 3 lots of orbits, K, L and M. So in the M shell, just like the L, it would also ideally like to have 8 electrons, and then it would be considered full in terms of valency. And the final one we're going to look at, KLMN. This is the N shell, and this shell would ideally like to have 18 valence electrons. It could hold more, but the magic number in terms of valency is 18. So I'll just go through this with you quite simply. So first of all, if you have one excess electron, so here we are, here's an atom, there's the nucleus, these 2 shells are in yellow because they are full. In this shell, there's just 1 electron. Now, the atom can do 2 things. It can either bring in 7 more to give it the stability it wants, or it can get rid of that 1. And which you think's the easiest? The easiest is to get rid of that 1. So it releases that electron. That electron goes somewhere with its negative charge. The atom that remains now has 1 fewer electrons than it does protons. So this atom is now an ion, and it has a charge of +1. And of course that orbital that's in white isn't there anymore. So this is a very happy atom. It's got 2 complete shells. If we go through exactly the same procedure for an atom that has 2 electrons in its outer shell, we'll see exactly the same thing. So there's our there's our atom. There is the 2 complete shells in yellow, and the third shell has 2 electrons in it. So what's going to happen? The 2 electrons are going to fire off. The atom becomes an ion. It has a charge of +2 now. And that orbital disappears, or that shell disappears. Finally, we'll do it for 3 electrons. So here we have an atom with 3 electrons. It gets rid of those 3. It now has a charge of +3. That orbital doesn't exist anymore, and again you've got a happy ion with a charge of +3. I'm going to skip 4 electrons for the moment and move on to an atom that has 5 electrons in its outer shell. So here we see 5 electrons. Now this has a choice of 2 things. Either it can fire electrons out like it did before, but it's got to get rid of 5 of them, or it could bring 3 electrons in. And I guess I've given you a clue here as to what's going to happen. It's going to bring 3 electrons in. So those 3 electrons will come in. That shell is now a complete shell. We have a happy atom or a happy ion because its charge is now 3 minus because it has 3 more electrons than it does protons. Similarly, for an atom that has 6 electrons in the outer shell. There's our atom with 6 electrons in the outer shell, neutral. 2 electrons come in to fill those 2 empty spaces. The ion now has a charge of 2 minus. And finally, 7 electrons. There's the 7 electrons. There's our 1 electron hovering in the distance. That electron will come in and take its place. That's now a happy atom or a happy ion. It has a full outer shell and its charge is -1. So far so good. Well, all of those are examples of how ionic bonding works. And if you watch the ionic bonding video, then you'll see this in a bit more detail. Just to give you some examples of how important this is, here are 2 groups from the periodic table. If you remember, columns going down are called groups, rows going across are called periods. So in group 1, every single element, lithium, sodium, potassium, etc., every single element has 1 electron in its outer shell. Therefore, everything in here wants to give away 1 electron. Everything in this group here, this is group 7A because I'm old, or group 17 for the youngsters, everything here has 7 electrons in the outer shell and would love to gain 1. Therefore, any one of these elements will combine with any one of those elements. For example, you could have lithium fluoride, you could have sodium chloride, you could have potassium chloride, you could have lithium iodide, etc. If the elements are not in the same, they don't both have this 1 electron problem. If you look in group 2, everything here requires 2 electrons from group 2. So everything in group 2 wants to give away 2 electrons. We'll stick with group 7A. Everything in group 7A wants to acquire 1 electron. So if this is giving away 2, then for example, we need 2 fluorines to associate with it, 1 electron for each fluorine. Magnesium chloride, magnesium will give away 2 electrons, 1 to each of 2 chlorines. Barium chloride here, that will give away 2 chlorines. So you see, if we carry on with these examples, if we had group 2 and group 6A, everything has 6 electrons. So everything in group 6A would like to acquire 2 electrons. So group 2 and group 6A will be back with a 1-to-1 ratio. I hope that makes sense. If you have any problems or questions, please let me know. So the one that we missed out was 4 electrons. So we'll do that now. Here's an atom with 4 electrons. Now, as you've seen, the atoms are quite happy to give away 1, 2, or 3 electrons. They're quite happy to receive 1, 2, or 3 electrons. But in this top part of the periodic table, 4 electrons is just a step too far. An atom cannot give away 4 electrons, and an atom cannot receive 4 electrons. Therefore, it needs another strategy to get a full shell, and the strategy is to share its electrons with other atoms. And that particular process we called covalent bonding, cooperative bonding. And again, if you watch the covalent bonding video, you'll see that in more detail. Finally, we need to talk about atoms that already have a full shell. So here is one atom. This has just one shell and it has 2 electrons in it. It's full. That's actually helium. Here is another atom. Had it been 2 shells, it would have 8 electrons. It will be full. This has 3 shells. It has 8 electrons. It will be full. Or you've this one that's got 4 shells. It's got 18 electrons. That one's full. These materials have no need to give away any electrons because they've got exactly what they need. They've no need to bring in any electrons because they've got exactly what they need. Therefore, they are very, very unreactive. And these are the elements that we call the inert gases or the noble gases. They don't react simply because they have no need to. They have full outer shells, and it takes a huge amount of energy to force them to combine with other things. Well, I hope you've enjoyed that particular video tutorial. As always, thank you for watching, and as always, if you have any questions or queries, please let me know, and I look forward to seeing you in another video. Bye for now.